All right, today's lesson is going to be talking about what happens when you have intersecting chords and circles. We're going to start with defining what a chord is. In a circle, a chord is always going to be a segment connecting 2 points from the edge of the circle. So any 2 points connecting a point on the circle to another point on a circle is technically a chord, which means a diameter is also a chord, but a chord's not necessarily going to be a diameter. It's got to go through the center to be a diameter. And as you know, the diameter is always twice the radius. So you can look at those 3 definitions just to kind of refresh your memory on that, especially with the chord, because you may have not seen that before. Now we're going to first talk about angles. An inscribed angle in a circle is an angle that is actually formed from 2 chords meeting at a same point on the circle. So in this case, chord AB, they share a vertex with chord BC on the circle. And that angle at angle ABC is an inscribed angle. It opens up to the arc on the other side. And it's always going to be half the arc. So let's say this arc is 80 degrees. That would imply that this angle is going to be 40 degrees. And a couple things about inscribed angles. Remember that a central angle is an angle in the center of the circle. It opens up to the arc with the same measure. So if this were 80 degrees, that central angle would be 80 degrees, but this is going to be half of it because it's pulled the other way to the other side of the circle. It's an inscribed angle. If you want to read up a little bit more about why that works, just click on the source for some more information. So how do you work these problems out? Well, a lot of these problems for the angles are just kind of multiplying or dividing by 2. So you have to decide what you're given. So in this problem here for number 1, you're given angle BPA. So the angle is the central angle, which means it's going to be the same measure as the arc out here. So since that's the same measure as the arc, then the inscribed angle is going to be half of that. So we would get x by just doing 104 dividing by 2. And that's going to give you 52 degrees. And you can try this one on your own. Check it with me in class. But you're given angle C, that's the inscribed angle. You want to get angle X, that's the central angle. So what would you do to get that? Try that on your own. Check it with teacher in class. All right, question 2. In this problem, we have to find the measure of angle WXY, which is an inscribed angle, but it opens up to the arc that we don't have a measure for. So to get that measure of arc, you have to know that all your arcs in a circle add to 360 degrees. So we would first want to add those 2 numbers together. And that's going to be 276 degrees. So this arc here is going to be 360 minus that. So arc WY, we always just say WY, put a little arc symbol above it. That measure is going to be 360 minus 276. So that should be 84 degrees. So now that I know that's 84 degrees, of course, the central angle is 84 degrees. We can figure out the angle over here in the inscribed portion of it. That's just going to be 84 divided by 2. So 84 divided by 2 is 42 degrees. So that angle here at X is 42 degrees. Try number 2. Check it with your teacher in class. All right, number 3. All right, in this problem, we have an angle AOB is 86. So if we draw angle AOB out, that's a central angle. That's 86 degrees, which means this arc is going to be 86 degrees. And although it's not directly behind it, the angle at point C still opens up to that same arc. So you're still going to divide 86 by 2 to get angle C, that X there. So that's going to be 43 degrees. So a lot of dividing by 2, multiplying by 2 in these problems. Go ahead and try letter B. Same deal. All right, that's question 3. Question 4, just kind of going through the relationship between obtuse, acute, right angle. So if you remember, an acute angle is going to be less than 90. And then an obtuse angle would be between 90 and 180. And then, of course, a right angle is 90 degrees exactly. So let's look at those 3 relationships as we remember. When we're doing an inscribed angle, if we're opening up to an angle, an arc greater than 180, remember we're dividing by 2. So if you divide a number greater than 180 by 2, what kind of angle is going to be formed? Is it going to be acute, obtuse, or right? Think about that, answer that one on your own. And then look at this one here. If you divide the 180 by 2, well, you know, that's going to be 90, right? So it doesn't matter what you get, you know, whether that angle is over here, as long as it still opens up to half a circle, that's going to be a right angle. So it's going to be a 90-degree angle there. So I'll be right. And then if you got an arc less than 180 divided by 2, well, if you're dividing a number less than 180 by 2, that number should be less than 90. So you can answer those 2. It should just be obtuse and acute and right. Just so you can see that relationship between what that arc is to that angle.